Good afternoon to those in the hearing room, and good afternoon to you, Mr. Wafer. Can you hear me clearly?
I can do, my lord, thank you.
As you understand, you're about to be asked questions by Mr. McKeever, who you should be able to see on screen, at least in due course. But before then, I understand you're prepared to affirm.
I am.
Would you repeat, sitting where you are, would you repeat these words after me? I solemnly, sincerely, and truly
I solemnly, sincerely, and truly
declare and affirm
declare and affirm
that I will tell the truth,
that I will tell the truth,
the whole truth,
the whole truth,
and nothing but the truth.
and nothing but the truth.
Thank you, Mr. Wafer. Now, we've scheduled you for the afternoon. It may be that your evidence does not take all that time. I simply don't know. But if you want to take a break at any stage, please just give me an indication and we can take a break. But
Thank you.
I'll now ask Mr. McKeever to begin.
Thank you, my lord. Could you tell the inquiry your name, please?
Timothy John Wafer,
And your occupation?
Director,
It's director of what organisation, please?
the Director of two organisations, Water Solutions Europe Limited and H2O Solutions Europe LLP.
Now, I understand you were involved in some work at the Queen Elizabeth Hospital in Glasgow from around June 2018 onwards, is that correct?
That's correct, from the 15th of June.
And in broad terms, that involvement concerned the establishment of a chlorine dioxide programme. Would that be right?
That was the primary assignment of the role, yes.
You've already prepared a statement in that regard for the inquiry, is that right?
That is correct, yes.
And are you content to adopt that statement as your evidence before it today?
I assume that this is the questionnaire that got sent out, is it?
Yes, the one that you've completed.
The one I completed, yes, I am.
Now, I'll refer you this afternoon to that statement, and when I do, it will come up on the screen in front of you. It may be that other documents come up from time to time. But first of all, could I ask you to look at page 1 of the statement, which will be page 63, I believe, of the statement bundle.
Is that coming up on the screen? Yes. Okay. Yes, I have that.
Okay, now this is question 1. You've set out some of the details of your career over 50 years involved with water in various disciplines. How long have you been involved with chlorine dioxide?
Oh, I would suggest 25 plus years.
I wonder if you could describe in broad terms what that involvement was. Was it designing systems for buildings or other work?
It was designing, implementing, managing, operating, and the use of chlorine dioxide across a variety of disciplines, not limited to healthcare.
Okay, thank you. You mentioned at the very start 2 companies or 2 entities that you're director of. Which umbrella did you work under when you were involved with QEH?
H2O Solutions LLP.
Later on in your statement, you've mentioned that Water Solutions Group is still involved at the hospital. But at that
H2O Solutions is still involved at doing work for Queen Elizabeth Hospital, yes, and Greater Glasgow and Clyde, yes.
Okay, I wasn't quite clear of that, and perhaps the misunderstanding's mine. When you say H2O Solutions and Water Solutions, are those different names for the same thing?
We have 2 businesses, Water Solutions Europe Limited, which is a limited company, and the original founding partnership, H2O Solutions Europe LLP.
Okay, thank you. And before I move through the statement, this isn't part of the statement, but am I correct in understanding that at some point you have carried out role as an authorising engineer?
Yes, I am an authorising engineer, and I carry that role out currently for a number of NHS establishments and major offering facilities management companies. Yes.
Okay, where is that you carry out those roles?
That they're for NHS locations in England and one in Scotland.
And I described it as authorising engineer. Is that authorising engineer in respect of water, or is there a further specialism to it?
Oh no, only water.
You mentioned 15th of July as being well, I've noted it's 15th July 2018 is the date in which you became involved with Queen Elizabeth.
Sorry, correction, the 15th of June.
Thank you. And if we go over to page 64 of the statement, you mentioned here in your answer to question 2 of having first had contact with Ian Powrie. Do you see that?
Yes, I do, yes.
Could you tell me how was that contact made, please?
It was made via, I think, and it's a long time ago to recall, I think it was either a phone call or an email trigger from Ian Powrie.
Did you know him before?
No, I did not. We did not know GG&C. We did not know Queen Elizabeth Hospital before.
Yeah, so did this communication come out of the blue then, as far as you were concerned?
Yes, it came out of the blue as far as we were concerned, yes.
What was the initial conversation or communication about?
The initial conversation was a very brief overview that there was some issues with water and that they were considering the implementation of a secondary control measure, and that we had been put forward, having done a number of these installations around hospitals in the United Kingdom, that we may be able to assist them, and we were invited up to come and have a discussion.
Were any papers sent to you at that stage?
Not at that stage.
Okay, you mentioned that you were told there were issues with water. Were you given any understanding as to what the nature of those issues would be?
Just microbiological issues, which is what we would typically expect anyway. So that wouldn't surprise us. When people contact us, it's normally because there are microbiological issues.
Okay, and we know that as matters progressed, it led to the introduction of a secondary control mechanism.
Yes, it did.
Was there any indication at that early stage that you were contacted that this was contemplated or had been decided on?
They had looked at a number of potential systems, and chlorine dioxide at that time was the favoured system. However, they wanted to have a discussion with myself as to how that could be implemented and suitability.
Okay, and just to be clear, was this at the stage of the initial email or phone contact that you learned that chlorine dioxide had already made its way to the forefront as a favoured system?
No, because there was virtually very little exchange of email at that time. The plan was that I was going to go up and have a meeting with Ian Powrie and discuss the whole thing with him face to face.
Okay, I'll come to that in a moment. But first of all, since we're in the territory of talking about chlorine dioxide, I wonder if you can just describe to us what it is, how it works, and so on.
Chlorine dioxide is basically an oxidizing agent. It's generated from two chemicals, predominantly sodium chlorite being the precursor, and an acid, which can be a number of acids: citric, hydrochloric, phosphoric. You can, and basically the acid activates the sodium chlorite as part of the reaction and generates chlorine dioxide. Chlorine dioxide is a gas in solution, and it's I suppose you could describe it as relatively unstable, give it energy and you can part it from the water, but it'll rapidly come back to the water. But it's a very effective agent at penetrating things like biofilms and the DNA structure of microorganisms.
Okay, now you're an engineer by background, and so don't feel that you need to attempt to give chapter and verse if it's not within your competence. But are you able to tell us how chlorine dioxide physically or biologically works in tackling these organisms?
In simple terms, it is absorbed through the cellular wall and disrupts the DNA structure of the organism, and thereby annihilates it. So you typically don't get recurrence of organisms once they've been attacked by chlorine dioxide.
Okay, we've heard some evidence that there are certain organisms for which it is much less effective, and that included some organisms present at the hospital. There was reference to one called Mycobacterium chlorine. Are you aware of that organism, and are you able to tell us anything about it?
Mycobacterium chlorine, yes, I do know about it because of work that we've done with another NHS organisation. And actually at that organisation we did not use chlorine dioxide. However, I think it would be true to say that all oxidizing agents can have a variety of performance depending upon the circumstances that you are giving them and the methods of delivery. So it depends. I mean, a lot of microorganisms have the ability to hide within either biofilms or other organisms, and it's whether or not the chemical that's chosen can actually get to them to actually kill them.
Specifically, were you aware at any point of the presence of the Mycobacterium chlorine at the Queen Elizabeth?
No. We were aware of a number of organisms, but not specifically that one.
More generally, what would the advantages or disadvantages of chlorine dioxide be as opposed to other potential biocide systems?
In some respects, easier to apply. The fact that it would actually work through biofilms and destroy biofilms, and therefore work as a removal, a cleansing agent, and that it is in some respects slower acting, and sometimes and therefore the rate of absorption works to our favour rather than necessarily being too fast. The level, I suppose, best thing is to describe it. The level of burn off is reduced.
Are you aware of electrolyzed water as a potential control mechanism?
I'm aware of many systems under many names, unfortunately. Yes, so electrolysis of water, yes, we've come across it, yes.
Moving on, it's question 3 further down that page. You mentioned that you were brought in for technical input. It's in the second line of your answer.
Yes.
In general terms, what does that mean, please?
To assist with the design and the dosing strategy that was going to be employed. So here we had to some extent, this was a fairly, I would say unique situation, because you had a very, very large facility operating from a centralized source. So it's how did we perceive that we were going to get the delivery of the chlorine dioxide from the centralized source dispersed around the facility? How effective was that going to be? How were we going to consider the differences between hot and cold systems?
Okay, I'll perhaps ask you a little bit more about that when we come to your visit in a moment. But sticking with the time before you had actually visited the premises, were you told before you went there about the degree of contamination that might be involved?
No, not before we got there.
And perhaps I use the word contamination.
Sorry, can I just clarify there? Not that we recall.
Okay. I mean, I used the word contamination there rather than risk putting words in your mouth. Is contamination the right word for me to have used there? What would you?
It's as good a word as any.
I'm wondering if you might then give us your understanding of what you would mean by contaminated.
Well, basically, that we would be looking at potentially microbiological contamination, which would be either specific organisms or general biofilm.
So what stage in the process would it been possible for you to form your own view as to whether you were dealing with a contaminated system?
Certainly, after the first few visits, we were able to develop a fairly clear understanding of what was required. In some respects, this was, at that stage, nothing more than we might have seen elsewhere with other systems. It was a contamination of a water system, domestic hot and domestic cold. It required a secondary control measure to improve the situation, and it was the implementation of that secondary control measure. And how did we make that robust enough to meet the demands of a very complex site?
So in terms of the language you've used there, secondary control measures, what in general terms does it tell you about a system if it's having to move to a secondary control measure phase?
Typically, primary control measures are that of we have a phrase that we use: keep hot water hot, keep hot water hot, keep cold water cold, and above all, keep it moving. And if you do that as your primary control, then typically you should be dealing with the majority of issues. Now, by that I mean that hot water needs to be delivered at 60 plus degrees and returned back at circa 55 and above. Cold water needs to be less than 20 degrees. And they are all defined within the SHTMs and the HTMs.
Does it follow from that then that if that is happening, and yet the system still needs to move on to secondary control, then you're dealing with a system that has gone out of control?
The system may have gone out of control for many, many reasons. It could be a failure in the circuitry or the flow of the water system. It could be lack of use in certain areas where you're getting stagnation. You might have parts of the building that are high occupancy and heavily used, and therefore you get good water consumption and good water flow, going back to my hot, cold, and moving scenario. And you may have other areas of the building where there's very little use of water. And whenever you get stagnation or low flow of water, that is giving the opportunity for biofilms to form. When biofilms form, that gives a home and a haven for microorganisms to develop.
Turning back to the page we were looking at, page 64 of the statement bundle. At the foot of the page, this is within the answer to page 3. The last paragraph begins by saying that WSG Water Solutions Group has had key involvement in the technical aspects of a number of key controlling biocide systems, predominantly in healthcare.
Yes.
It may be that you've told us as much as you wish to tell us at the moment, but I wonder, could you explain in summary anything further that... I'll start again, sorry. Can you just simply explain to us what that means, please?
Yes, so basically, for a number of healthcare establishments, major hospital environments, we have designed, implemented, and verified the performance of chlorine dioxide systems within those healthcare premises. And some of these are from new to very old hospitals.
And when you say within that phrase technical aspects, can you give us an indication of what that means, please?
Well, that's coming up with the capacity of the dosing systems that are going to be employed, the monitoring, where we need to put monitoring devices to measure the chemical levels within those water systems. Yes, and the necessary control and dosing strategies that need to be implemented.
In the next sentence, due to the complexity of the water system, IP, Ian Powrie, required WSG to work with facilitators of the biocide systems to ensure the necessary control measures and dosing strategy was implemented. Can you explain to us what you understand was meant by that?
Yes, so in essence, we were going to come up with the philosophy and the strategy that was going to be employed. We do not supply or manufacture or install any of these systems. So we were going to work with and liaise with the organizations who were going to put that in. So in this instance, we had a company who were going to provide the chlorine dioxide equipment, the generating equipment and the monitoring equipment. We had another organization that were going to do all the engineering works, that were going to have to modify the pipe work to handle all the installations that were necessary. And with that, working alongside the necessary mechanical and engineering contractors.
So I should understand you as being the designers, the directors of this project, whereas other people were the contractors.
I wouldn't say designers and directors. We provided the technical support from the initial design of the strategy. If you, depending upon which manufacturer you would have gone to for the equipment, they might have had a different view on how they would have implemented it. So it was, did we agree with that implementation?
Okay, thank you. If we could turn over the page, question 4 is on page 65. And the question here you'll see was asking about between initial contact and your visiting the hospital, did you have further contact regarding your task? With whom, further information, and so on. Your answer starts by describing meeting a number of people, and you give 4 or 5 names there. I mean, just to be clear.
Yes, well, I mean, on our visits to the sites, to the Queen Elizabeth, we obviously met with a number of people. Whilst Ian Parry was our primary point of contact, we obviously needed to meet with people like Colin Purden and Melville Macmillan, who were on the engineering and estate side. We met, obviously, to do with the water technical group. There was Mary Ann Kane and Alan Gallagher. So these are, and many other people. They were just a few examples of names.
Right, but I should understand these to be meetings that took place at the hospital rather than meetings that took place in a kind of intermediate stage before you visited the hospital. Is that correct?
You know, the majority of the work we did was done at the hospital.
How do those meetings come about? Who arranged them for you?
Ian Parry. So we would develop I suppose, a task list of things that we needed to do. We would get that together. There would be an exchange of emails regarding that, and then we'd organise a visit for me to go back up to the hospital.
And what sort of things did you learn from those meetings?
More about the water systems than the issue itself. So all our questions came about the way that the routing of the water through the hospitals, getting hold of drawings, getting hold of water consumption data, or get more of the technical data involved in the water systems themselves, rather than necessarily being the microbiological issues.
I'd like to ask you about your initial impressions of the site. You alluded to this earlier on, but if we go over the page to 66, this is when you're describing your visit to the hospital.
Okay.
I'll just ask you, in general terms, what were your impressions of, firstly, the size of the site?
Enormous. It was a very, very large facility. And I think, as I stated here, my initial impression was that, given the size of the facility and the spread, in other words, it was large and drawn, and that our view was that there was a vulnerability due to, if anything happened in the central plant room, that went everywhere, because everything came from a centralized source.
You've anticipated my next question, which was I'm going to have asked you separately about the size of the water system. What were your impressions of that?
Do you mean the overall size of the hospital water system, or are we talking now about the plant room?
The overall size, but you can move on to the plant room as well if that's relevant.
Okay. It was big. It was vast. It had a number of delivery points, i.e. it had what we call risers, so that where the water went up and then was disseminated out. But everything was delivered from this one centralized plant room.
And does it follow from that you were immediately struck by a point of vulnerability in the system?
Yes, I was, because whatever went wrong, if anything went wrong in that plant room, it went everywhere.
Did you become familiar with the plant room?
I would say intimate. Yes, yes, intimately concerned with it. We got to know the plant room extremely well, because the plant room, in some respects, was our first starting point for the chlorine dioxide system. The chlorine dioxide systems were going to start in that main plant room and emanate out from there.
Now, you suggested in your answer a moment ago that I might make a distinction between the size of the water system and the size of the plant room. Have you got any remarks to make about the size of the plant room?
No, not specifically. No. I got comments to make, as I think I've already said, within question 5, that there was a concern that we picked up on about the damp, and there was an overriding smell of mold within that plant room, and I think from discussions there was a potential ventilation issue with it.
Could you elaborate
and that was not just picked up by myself, that was picked up by others as well.
Okay, you can maybe elaborate upon those points, the points that are made within 5. The damp within the plant room, what were your thoughts on that?
Well, I think one of the problems was that the plant room was actually, for want of a better word, below ground. Any water that was contained within it was pumped out, so it had to be pumped up and out of the plant room. So if you had any work going on that was in there, the water then basically went to a collection pit and was then pumped away. And I think the potential lack of ventilation or air changes created an environment for mold to develop and for mold to exist. I know, talking on site with another colleague up there, that we said that we identified that there was the main air intake for it came through the services corridor, which ultimately impacted on the water plant room. The air intake for that services corridor came from typically air that had come very close from the sewage treatment beds that were located near the laboratory building. And I think that was a general thing. And I think that's why we came back and said that, was this right as part of the initial design?
Okay, well, perhaps can I ask you specifically about that. What was your concern about the proximity of the sewage works?
Well, if you've got the wind in the right prevalent direction, then obviously sewage treatment beds are loaded with loads of bacteria, and that obviously can get picked up and drawn across and into the ventilation system, and that was a concern that we had.
Did you have that investigated at all?
There was certainly investigative work was undertaken, not by us.
Do you know who by?
That was done by Greater Glasgow and Clyde, who did air sampling investigation work.
Are you aware of the outcome of that?
No, we never got to see the results of that.
I wonder at this point, if I could refer you to a photograph, which we have. This will be the end of the list of documents. We've got two photographs that recently came to our attention. I don't know in which order they're going to come up with.
Okay.
That's the first one. This is perhaps not very illustrative. Can I see the second photograph, please? There we go.
I'm just trying to work out where that was. Okay, yes. On the floor. Yes, I think, yeah. And this was one of the issues. We never.
I wonder first, if I can first just ask you before you give us the narrative, do you recognise the room?
I recognise the room. It's in the bottom right. It's in the far corner of the plant room, and you actually have to climb up the steps and go through that door to get into it. Yes.
Okay, so if we see on that page at the top, there's the narrative basement plant room, and at the bottom there's a narrative about the door being at ground level. And I think you mentioned the ground level intake a couple of minutes ago. As far as you're concerned, are those narratives accurate? Is that what this is showing?
So the door in this picture is at ground level. It was ajar, and you can see water running down the wall. I can't comment about the water running down the wall because we never saw that. What we saw was a damp condition, but we didn't see water running down the wall.
Okay, well, that's fair. And you mention, if we turn back to the statement, within that answer 5, you see you've made reference to damp conditions within the plant room.
Yes. Yeah. The plant room always had a damp feel to it, and there was always a background odor of mold. And that was commented both by myself and by when I met up with Dr. Tom Makin up there and we went to the plant room together, we both immediately looked at each other and said, yes, we can smell mold.
I'll perhaps treat those two things separately insofar as they are separate. You mentioned mold, perhaps an obvious question, but what's the problem with the presence of mold?
Well, the problem with the presence of mold is that it leads to other scenarios and other conditions that we don't want to see in in water systems. We don't want mold in water systems, and we don't want mold within those environments.
The reason for that is what?
It provides a lovely food source for microorganisms.
Okay.
We see this in when you've got houses that have had flood damage. One of the things that you've got to address is mold, because the mold will thrive in those damp conditions, and that then leads to things like aspergillus and so on. So, you know, within the hospital environment, you certainly would not want that. You wouldn't want it in any environment, quite frankly.
Yeah, and as you say, that the smell of mould was very clear to you and to Dr. Macon.
Yes, it was.
Now, just to be clear in this, is the odour of the mould an issue, a separate issue, or not?
It may be. You couldn't definitively say that. You would need to do air sampling analysis to be able to fully detect that and understand. You'd need to know how much mold there was, and for that you have proper air samplers where you take the samples and you do the analysis from there.
Okay, I mentioned the second point that I was interested in from your answer a moment ago was in relation to the damp conditions within the plant room.
Yes.
Now, you've mentioned, not here, but I think further on in your statement, the presence of, or the storage of components within the damp plant rooms. Do you recall that?
I recall the storage of components within, because there was more than one plant room. There was the main water tank plant room, which did the filtered water, the raw water, the filtered water, which went out into the hospital. Next door, there was a fire suppression water system and a big water storage tank there, and a lot of components were stored within that environment.
Right. Were both of those environments damp?
Yes, they were. One of the problems being that the fire water storage tank had got a persistent leak, which was coming from the bottom of the water tank, which could not be gained access to because they'd installed the water tank directly onto the concrete surface rather than putting it up on pillars so you could actually get access to the underside.
What issues were you concerned about as regards the storage of components in damp conditions?
So components need to be kept clean. They need to be kept clean from the environment. They need to be kept clean from dust, from damp, from mold, because you know that can provide a source of nutrient, anything there, for microorganisms to develop and grow on. So having boxes of components open to the atmosphere was not the right thing to have. When we look at new constructions today, we talk about components being wrapped, sealed, copper tubing capped at both ends. And the reason for that is that we want to stop the potential for ingress of dirt and damp and anything from the environment to get in there.
And was that not what was happening at the Queen Elizabeth when you saw it?
When we initially saw it, that was not what was happening.
What did you do about it?
That was addressed, and that was an action that was taken up by estates to actually resolve that and get those components moved and into a better environment.
Okay, I don't know if you still have question 5 up on your screen.
Yeah, I've got it, and I've got it printed as well, so I can put it both ways.
Thank you. The last paragraph, the last 5 lines, I'll read them out to you. The impressions fitted the described scenario, but the task was more urgent and going to be more complex from an engineering perspective due to the need to install some 29 chlorine dioxide systems. It was not the task required change, but the amount of biocide systems that were going to be employed increased, which had an effect on timeline. Could you explain to me why were 29 systems required?
So we had the water tanks within the basement plant room, the centralized plant room. So we wanted to treat the cold water with the chlorine dioxide, and because of the various demands on each of those 4 tanks, we needed to install separate chlorine dioxide systems for each tank. So that took up 4 systems. There was also, within that plant room, we had the ultrafiltration plants. So the raw water came into tanks, then went through the filtration plants, and then into the filtered water storage tanks. And the filtered water storage tanks then went to the hospital. So, so the 4 systems were dealing with the 4 filtered water storage tanks that took the water out to the hospital. But we also needed to protect the filtered water plant membranes, because on the reverse side of the membranes, because they are removing any debris, organisms and everything else, you can get biofilm form on the reverse side of those membranes.
When you say the reverse side of the membranes, is this the part of the membrane facing the mains supply?
This is the part of the membrane that would be facing the raw water supply. Yes.
Yes.
And so effectively we utilise the chlorine dioxide. Those membranes are periodically go through what we call a backwash cycle to wash off any debris. So we utilise chlorine dioxide on those membranes to provide some assistance to keeping those clean as well.
Right, and did that necessitate another 4 systems?
That necessitated, there were 2 filter plants and there was a 3rd plant being installed as part of the improvement programme. So that ended up being 3 additional systems. Okay,
so does it follow, you've already told us about the size of the system, your impressions that this was a vast system. If 29 systems were required for chlorine dioxide, is that a function of simply of how large the system was?
Yes, it is, because the other systems were then employed on the hot water. And the hot water was generated in various parts of the hospital, in various plant rooms. So you didn't have a centralized hot water generation. Hot water was generated in the plant rooms that were located around the facility. And that's where we had to put the remaining systems. So each hot generation system had its own chlorine dioxide system.
Okay.
So if we do the maths, we've got 29 in total. 7 went into the basement, and then the remaining 22 systems were utilised around the site.
Okay, thank you. Just perhaps put that in context. Again, you mentioned already that we're dealing with a vast system. Any typical job, insofar as there is a typical job, how many chlorine dioxide systems might have been required?
We have never done a system that required that many.
What might the next largest number have been?
5 or 6.
And I suggested that that was a function of the size.
It was a function of the size and the fact that we wanted to get the chlorine dioxide disseminated throughout the whole of the system. There's 2 approaches you can make here. One is you can dose the system, you can start chemically dosing centrally and allow it to disseminate out through the systems, which will take longer. Or you can put more strategically located units around the site so that you can speed up the input of the chlorine dioxide. so it doesn't take as long.
And is the size of the system also impact upon that calculation that you're making at that point?
Yes, it does. Yes.
And again, the inference I'm drawing is that if you'd had one central chlorine dioxide plant, then it would have taken an awful long time to get round to the extremities of the system.
Oh, it would have taken. I'm often asked by people, how long does it take? And the answer is, you can't give anybody that prediction because you don't know the amount of biofilm and contaminants that are in those systems. So but you can balance the equation by basically looking at it and saying, okay, because that system has got a level of complexity, then we need to put more than one plant in.
Was there a complexity to the system separate from its size?
No, I think the system was straightforward. You know, it had a flow and a return on the hot. The cold system, whilst it was large, yes, it went out through the various booster sets and up the various risers to get it to where it was needed. So no, I mean, it was an orderly system.
One feature of it you've mentioned later in the statement is dead legs. Can you explain the issues you encountered with those, please?
I think today we have a better understanding of dead legs. I think if you go back to maybe 2018 and certainly 15 when this thing was constructed, I don't think we had the awareness of dead legs in the same way we do today. So a dead leg basically provides an opportunity for organisms to find a home and grow and develop because they're not disturbed. It is a dead leg. The water does not move through it.
Can I, excuse me, Mr. Keever, can I just take you over that again? To the layman, that's, if I've understood you, that's quite a remarkable statement that, as I understand it, you're talking about the general understanding within the industry of the significance of a length of piping with water in it, not having a flow of water. In other words, stagnant water.
Yes.
Now, as I say, to the layman, the notion that as recently as 2015, there was less of an understanding of the significance of stagnant water as a source of microbial growth, which has changed in the last 9 years. Now, first point, have I understood your evidence? And I think secondly, I would invite you to expand on that because, again, to the ignorant layman, the notion that stagnant water might be an attractive environment for microbial organisms doesn't seem so remarkable.
I think if we, and maybe we need to break this down a little bit, if we are talking to people who are in our industry, people like myself, we understand and always have understood to some extent dead legs and the problems they cause. That then has to cascade down, and that has to go then down to the people on the shop floor, the people who are doing the installation work, the people who are doing the changes and putting in pipe work. And a simple example, is, we've installed a sink, it's in the wrong place, we'll chop the pipe and put a cap on the end of it and move it somewhere else. That's creating a dead leg. Does the plumber, does the installer actually think about that? some time ago, no, they didn't. I think they do today. They're far better educated today. And they understand it more because we, in our industry, keep beating everybody over the head about dead legs. So, you know, I think that, so yes, there is a general there's a better awareness as people like myself and my colleague authorizing engineers and engineers in water get involved. More we are educating more, and as such that is being picked up on more. Sorry, I possibly haven't put that over particularly well.
No, I think I've understood your position. Thank you.
Yeah, I asked the question with a slightly different interest in it. The particular interest I had related to your position as someone who's interested in getting a particular chemical to circulate throughout the water system. Could you summarise for me the problems that dead legs present for that?
So we cannot assume that if we have got water, chlorine dioxide treated water flowing through a water system, that it will actually go up a dead leg, because it won't. You might get some dynamic movement caused by variations in flow and that type of thing, but you won't get as much chlorine dioxide as you more likely would require up that dead leg, and so it still provides the opportunity for the organisms to develop.
When you first encountered the system at Queen Elizabeth, did this jump out at you as a problem?
Almost every system we encounter jumps out at us as a problem because dead legs always seem to appear. And I think it's partially down to the lack of understanding of what a dead leg is.
Would you like to expand on that answer? Maybe just to absolutely clarify what Mr. Wafer means by a dead leg, which is not generally understood.
So let me explain it by saying you have a length of pipe, and off that pipe you've got another pipe coming off it to provide a drain, and you install that off a T-piece. You install a drain, which basically never gets used. It just sits there as a point to drain the water out of the system. But it might be, you know, a very short length or a very long length. This is still a dead leg. The longer it is, the bigger the dead leg it is, and the bigger the challenge.
If you move over the page to 67, towards the bottom of that page, I might perhaps have taken you to this earlier, but if you see the second last paragraph, you're referring to discussions around dead legs within the water systems and how chlorine dioxide would react to these. Do you see that?
Sorry, which question are we on? Sorry.
Question 7.
7, right.
And it's at the foot of the page where question 7 starts.
Yes, there was also reference and discussion around dead legs within the water system.
Yes, and you, in the second sentence there, the action was to either remove, re-engineer, or place on a robust flushing regime.
Yes,
Could
so
you tell
basically,
me what each of these three means?
So you either cut them out completely.
That's remove.
That's remove the dead leg. So you engineer it out, or you modify it to such a way that it's no longer a dead leg.
Could you give me an example of that, please?
You could route it so it's used somewhere else. So you could actually convert it into something that's used, so you get water flow through it. Or you have to put it on a flushing regime, which basically says somebody has to go around once, twice a week, or daily, or whatever, and empty the water out of it. So you draw fresh water in.
Now, 2 questions from that. You use the word robust to describe the flushing regime. What do you mean by robust?
what I mean by that is that you don't the flushing frequency and the volume of water that passes through, first of all, washes out the complete length of the capacity of the dead leg, and that it's done often enough to prevent the growth of biofilm and the stagnation.
If we think back to when you, maybe 20 minutes ago, when you started describing the ideal water system to me, working on the basis of temperature and movement, how does the presence of dead legs affect that ideal?
Typically, you will not get. We're trying to be, I think, too general here, but you won't get, for example, on a hot water system, if you've got a hot water pipework flowing at 60 degrees, depending upon where the length of the dead leg and the size of the dead leg, you may not be able to maintain that 60 degrees up that dead leg. So it can impact on your control and operating strategy.
Okay, thank you. I took myself slightly out of order when I moved on to dead legs. If we could go back a page, please, on to 66 of the bundle, questions 5 and 6. Question 6, in the last third of the page, is asking you about a DMA Canyon risk assessment dated April 2015. And you've said you weren't provided with sight of this document.
No, we weren't.
And you then go on, any interpretation from findings and recommendations would have been provided by Ian Powrie. And then you say, as our involvement commenced June 2018, the 2017 document, and dealt with in the next question, would have been more appropriate.
Yes.
I just want to explore that a little bit, because later on, you move on to discussing your thoughts about whether contamination might have originated in the construction phase and certain things that happen during the construction phase. Is that correct?
That's correct. Again, another generalism, but we see a lot of problems originate during the construction phase.
Okay, and given that construction phase went on to the start of 2015, does it follow that it would in fact have been useful to you to have seen the risk assessment carried out at the start of 2015?
It would have been useful, I think, but potentially more importantly, to have seen what actions, any actions that came out of the 2015 risk assessment had been completed. That would have been useful. But bearing in mind that we were focusing here on the installation, implementation and operation of the chlorine dioxide regime, that was our primary focus at that time.
I appreciate that. The issue I'm trying to tease out is whether and to what extent it would have been important to furnish you with the whole history of what had happened in order that you best design strategy.
The more information we get, the better it is. However, we were not the authorising engineers here, and that would be more appropriate for the authorising engineers than ourselves.
Can you explain that to me, please?
Sorry?
Can you explain to me why, please?
Well, you know, the authorising engineer is responsible for basically doing the audits and reviews of what needs to be done, what's been identified out of the risk assessments. Whereas our focus here was, how do we get this chlorine dioxide system into this building in an effective way in the shortest possible time? Okay,
well, perhaps you might correct me, but I'll hypothesize to you that the purpose, or one of the purposes of the chlorine dioxide system might have been to, for example, remove biofilm where it had built up within the water system, right?
Yeah, correct.
And part of the information that would have been useful to you would have been the extent of biofilm that you might have expected to be inside the pipes and fittings and so on.
You might not have known that even from the risk assessment. Nobody is doing a measurement of the biofilm, and certainly not at that time. Yes, today we can get measurement of biofilm and we can get a better understanding of the presence of biofilm. But certainly back then, that was not something that was readily available.
Nevertheless, had you been given the 2015 report, it would have furnished you with more information about the history of what had been observed about the system.
Yes, it would have done, yes.
Would that have assisted you in designing a strategy and coming up with a solution that was appropriate?
No, it wouldn't have altered the way we went forward with the strategy.
Okay, thank you. Now again, back over the page at answer 7, page 67 of the bundle. Looked already at dead legs at the bottom of the page. 2 paragraphs above that, you start off the paragraph beginning, however, meaning the 2017 report, does highlight vulnerability of the filtration units located in the water tank room. Can you explain to me what that means, please?
There were issues identified with the way the filtration units had been connected and piped together.
What were those issues?
From memory, and I'm struggling to remember, I'm sure it was to do with the resilience of delivery. If one went down, it was not necessarily as easy, but that is from memory, and that was corrected during the installation of the 3rd filtration unit, and as part of the repiping that needed to be done for the chlorine dioxide anyway.
Is there an easy answer as to why a 3rd unit was required at that point?
Greater resilience, because there was you've got 2 units there which were pretty well in full demand. If one went down, you possibly didn't meet the demand that could be placed upon the hospital if there were times of high load. So hence why you needed an additional unit to provide that resilience. So you could always have two units operational with a 3rd out of action if need be.
Right, thank you. I've got another feature of the water system that I'd like you to tell me a little bit about, please. It may or may not relate to filtration. You can explain that to me. At bundle 27, volume 13, please, at page 87. This will come up on the screen in front of you. You'll see here there's a short exchange between yourself and Dr. Inkster relating to fungal cultures.
Yes.
Now the focus here appears to be upon point of use filters, is that right?
So I think this is looking predominantly to do with wards 2A and 2B, isn't it?
That's what's referred to. And if you look at Dr. Inkster's originating email,
yes,
this 4 out of 30 failures in wards 2A and B is referred to.
Can you just slide that down for me so I can see my response in total? Other way, please. So here we were talking, I think, about the performance of point of use filters.
Is this a matter that's related to chlorine dioxide, or is it a completely separate issue?
It's a completely separate issue. This is something aside from that. This is not related to the chlorine dioxide. This was part of some other work that Ian Parry asked us to get involved with, which was to do with point of use filters.
Was
And
there
if memory, and from memory, this is where I believe there was a question mark raised over whether or not they might have had some faulty filters, or allegedly faulty filters, and was there a quick and accurate testing method that could be utilised to determine if they were performing or not?
Did you ever come to a view on that question?
Yes, we did. Both from Powell, who took some filters away and came back and said there were no faults, and B, we had some filters in the laboratory, and I'm just going to go into my pile of paperwork. Yeah, we had some of those filters into the laboratory, and we examined them, tested them, cut them open, had a look at them, and we could not find any fault with those filters at all. They were doing the job they were supposed to do.
Okay, thank you.
They were preventing the throughput of the microorganisms. However, I think there was the potential for contamination in the outlet spout of the point of use filter, because that's after the membrane. So you've got the nice clean water coming through the filter that's got to come out through the spout. There was a potential for retrograde contamination on the spout and on the body of the filter from either the surroundings or from the drain that may well have been nearby.
Yeah, and in short, is that if something outside touches the filter, it might make the filter dirty. It's as simple as that.
Makes the filter dirty, yes.
Okay, thank you. I don't need to explore that anymore with you. Now, all this has been leading up to the designing of the chlorine dioxide strategy. And if we're back at the statement on page 68, is where question 8 is. And the question there is asking about a chlorine dioxide group being set up. Could you explain to me the process for designing a strategy? Who was involved? And what was the starting point?
So basically, first of all, we had to lay down a specification, what we required, and identify the location of each unit. And then once we got that all together and into a document and clearly defined, then we had to then bring together a chlorine dioxide provider, an M&E contractor, and the relevant support engineering and support governance within within Greater Glasgow and Clyde, so that we could actually form a working group to work through this, to make sure we got the amendments to drawings, that we got the operating manuals, that we had all the risk assessments in place, and that the chlorine dioxide systems went in as required.
Could we take the statement back just one page again for the very end of your answer to 7? Where you've said that in the initial period, Ian Parry was very specific about what he required as part of the remediation programme. Firstly, is the remediation programme, is that referring to the chlorine dioxide?
That's referring to the installation of the chlorine dioxide. He was very specific. He had a clear vision of what he wanted, and it was basically how he and I brought that together. If you like, we took his vision and interpreted that into a working solution to be installed within the hospital.
You were engaged for your expertise in designing chlorine dioxide system. To what extent were you influenced by that vision that you're describing?
No, I don't think we were influenced by it. It was I'll use the word loosely, it was a partnership. It was about Ian had the knowledge of the site, which we didn't have. We had the knowledge of the chlorine dioxide, which Ian didn't have. And it was a marriage. It was bringing those two together to come up with the solution.
Okay, thank you. We flip back over to the next page, question 8. Now, you've mentioned a number of specific elements to the programme: generation technology, service providers and provision, engineering works required. Now, you've mentioned, I think you've covered all of those already in your answers, but you then go on to work through specific high-risk areas which could be impacted on the chlorine dioxide, for example, renal.
Yes.
Now, before I ask you questions about that, could I bring up Bundle 27, Volume 13, page 89, please? So there's an email exchange here between yourself and Ian Powrie. And in the middle, on your email on this page,
Yes.
the middle sentence is relating to renal treatments. Renal treatments area are always subject to review and covered under a standalone risk assessment, which is normally completed by ourselves. Now, this email is dated 11th of July, 2018, so around a month after your initial engagement. Does this show that renal ward was always a special case in your mind?
Yes, it's whenever we go and do a chlorine dioxide consideration, one of the first questions we ask is, have you got a renal facility?
Why is that?
Okay, so we have domestic hot and we have domestic cold systems, but with a renal facility, we have dialysis water systems. So this is a specially ultra pure water that is used, and it's generated by going through water softener, carbon filtration, and then reverse osmosis technology to provide a very pure water which has to meet medical device criteria. So the last thing you need is chlorine dioxide getting through that, because oxidants can cause issues to the dialysis of renal patients, to an extent that it can actually lead as far as death. So you are always ultra careful when you come to look at chlorine dioxide and renal installations.
What did you do to take account of this?
So there's a number of things you do. First of all, you ensure that you have installed GAC filtration, so it's granulated activated carbon filtration. Carbon filtration removes the element of chlorine and chlorine dioxide. So that will remove it before it gets into the reverse osmosis plant. The next thing you do is that you because we talked about not only do you have a chlorine dioxide generation and dosing system, you also have a monitoring capability, because you have to know what levels you're putting in. So we would have a monitor that measured the chlorine dioxide arriving at the renal department, and then the chlorine dioxide post the carbon filtration, after the carbon filtration, to demonstrate that the carbon filtration was removing the chlorine dioxide. Now that was we then went through that. It's always the way when you want something. That was then discussed in detail, not only with Ian Powrie, but the renal department and the renal technicians and health and safety and everybody else, to make sure that we had a set of criteria. And we came up with a basically a protocol. I don't know whether you can actually see that, but basically we developed this, which was the protocol. So you had the chlorine dioxide that would be measured before, what alarms would be initiated, what actions would be taken if the alarms went off. So, for example, if greater than 1 part per million, close fill valve to tank, open dump valve, and ensure booster ClO2 plant in the basement is suspended. BMS alarm text to renal technician on call and the state's duty manager operating 24/7. We made sure that wherever there was renal operations, there was that facility.
Okay, thank you. You held a document up a moment ago. It wasn't one that I'd referred you to. I
Yes.
wonder if you could perhaps pass a note to the inquiry after you've finished with the evidence as to what that document was, please.
Yes, I can do. Yes.
Yes. But otherwise, if I'm asking a question and not taking you to a document, I'm content for you to answer off the top of your head.
Okay, thank you.
Now, when it came to putting in place the strategy, you were involved, I think, in 2 groups, chlorine dioxide group and water technical group. What were the roles, respective roles of those 2 groups?
So the chlorine dioxide group was to cover queries raised by M&E contractors. So if you like, you have the theoretical design side of the chlorine dioxide strategy, but then that's got to be implemented into the practical side. How are the M&E contractors going to get this installed? How are the chlorine dioxide providers going to do the installation and how are we going to make this work? So my role was to answer any technical issues that came up, come up with ideas and solutions where we found problems or we found issues that we needed to work around. That was my role within the water technical, within the chlorine dioxide group.
Okay. And the water technical group, was that different?
The water technical group was basically more keeping the water technical group up to date with what was going on with the chlorine dioxide and sharing, I suppose, knowledge that we had from other hospitals, other sites, because often everything is very insular.
Okay. Could we turn back to the statement, please? Page 69 of the bundle, question 9. And this is a general question asking about the strategy that you produced and when it was finalised. Firstly, could you summarise for us what the strategy was?
Well, so there was an urgency to deal with wards 2A and 2B because they wanted to get some chlorine dioxide dosing into those areas sooner.
Do you know why that was?
That was because there had been the issues around patients and various other microorganisms.
Okay.
And so one of the first tasks was how can we, in inverted commas, lash something together and get it in there and get it dosing quickly. So there was an installation initially of chlorine dioxide systems up on ward 2A and 2B. That was the first priority. Then basically we then started on the water tank room. How fast can we get that into the water tank room and get it operational, meeting the engineering challenges that we had to do? Bearing in mind that, when we have to come to modify pipework, we can't just turn the system off, because if we turn the water system off, we starve the hospital. We were dealing with this centralized plant room with no ability to be able to get water from anywhere else.
Now, you mentioned 4 dates in that first paragraph. Design work starting June 2018, and you've told us about that.
Yeah.
Implementation programme commencing in September 2018. What was that? Is that the wards 2A and B that you've talked us about a moment ago?
It would have been about that. I'd have to go back and look at the commissioning sheets to get the exact dates.
And when you say water tank plant room units became operational December 2018, is that different again?
The water tank plant room, they were the 4 systems that went into to get the filtered water, the cold water that went through the hospital dosed. They became operational December 2018.
And then you say other systems operational during first half 2019.
And they were predominantly the hot systems and the filtration plant systems, yes.
Why were there different dates? Why not commence everything at once?
Because you've got a lot of equipment and a lot of engineering work to do that's got to be planned and phased in. Had this gone in on day 1 before the building was occupied and before you had patients there, you could have looked at the strategy of putting it all in at once. But trying to implement with all the work that was needed for, not only have you got pipe work changes, but you've got cabling, you've got building management system interfaces to get into place. That's all got to be installed, checked and verified. And that takes time. And we had some fairly significant pipe work changes to do in the plant room, the central plant room, and that required a shutdown of the water supply to the hospital. So that had to be programmed in as well, and due notice given.
I was going to ask you from which of these dates or any other date should we understand the chlorine dioxide system as having been operational? Is there an answer to that question?
December 2018, because it is dosing the water going into the hospital for domestic use and for the hot water use and everything else. So it's the water that was being delivered from the main water tank plant room. So December 2018 is I would say is the critical one.
Okay. And again, I would have asked you why it took till then to get the system up and running, but have you covered that already by describing the works?
I've covered that already, yes.
So if we take that as the key date, how long would it take for the chlorine dioxide to permeate the system and begin to have the intended effect?
It's an unknown, 6 months to 5 years.
Could you elaborate on that? Why is it so unknown?
Because you don't know what biofilm is in the system. You don't know what is going to consume the chlorine dioxide.
Explain to me, consume chlorine dioxide.
Right, so we have a litre of chlorine dioxide, and in that litre we have 0.5 part per million of chlorine dioxide, and that 0.5 part per million of chlorine dioxide will be consumed by things that it comes into contact with, like microorganisms, like biofilm. So you're only putting it in at a certain level because people are going to be drinking the water, or it's going to be for domestic purposes. So you can't go and suddenly say, oh, I'm going to put in 10 parts per million, because we can't do that, because that would make the whole thing unworkable. So you've got limits to what the amount of chlorine dioxide you can put in. So I suppose you've got an equation here which says, how much contamination have I got, and how much chlorine dioxide do I need to get rid of that contamination? Unless you know that, which we don't, you've got to take it's contact versus time. It's the CT value.
Okay. I asked you before about the 2015 DMA report, and you said that wouldn't have changed how you'd gone about the task. But the information that was contained within that report, might that, insofar as you're aware of it, might that have been able to allow you to make a closer estimate of time rather than 6 months to 5 years?
No, it wouldn't have allowed you. because it also in that equation makes an assumption that it's going to get everywhere equally, and it's not, because the chlorine dioxide is only going to get to where it's needed by the taps being used. You've got to draw the chlorine dioxide through to the outlet. If it doesn't get to the outlet, it serves no purpose.
And the flushing you mentioned before is obviously part of that process.
The flushing is key. Use and flushing are the two key factors.
Okay. Sticking to your answer to question 9, the second paragraph is mentioning how the strategy employed a robust, tried and tested high purity generation technology so as to avoid unwanted byproducts. Chlorites in brackets there. Is chlorite the unwanted byproduct?
Chlorite and chlorate are the unwanted byproducts. The Health and Safety Executive HSG 274 Part 2 guidance gives figures for the level of purity that you need to get for generation technology. Now, okay, if I go back 25 years, we had a lot of very impure chlorine dioxide because we didn't have the ability to deliver accurately the amounts of chemical required. Today, we have very, very pure, high purity, and in fact, ultra pure chlorine dioxide delivery.
Now, you've touched in your last couple of answers upon purity, upon 10 parts per million not being an achievable level. Is this because chlorine dioxide has a toxicity about it?
Yes. Right back at the beginning, I explained that it's a gas in solution. So if you turn a tap on and take a kitchen sink, you turn the tap on, it impacts on the surface below, that will drive off the chlorine dioxide gas that's in the solution. So you can't have too much there. So there are prescribed levels defined in the Drinking Water Inspectorate guidelines, in the World Health Organization drinking water guidance, where they define the maximum levels you will have for water used for human consumption in domestic environments.
How do you go about keeping concentrations within the required parameters?
So you measure the volume of water, for example, on the water. So take a water storage tank. You measure the volume of water going into the tank. You do the measurement by using what we call an impulse water meter. So every time a litre or 10 litres or 100 litres goes past, it sends out an electrical pulse. That electrical pulse then operates dosing pumps, which then deliver an accurate volume of chemical, which is directly proportional to the amount of water going in. So in essence, the faster the water goes in, the more chemical goes in. The slower the water goes in, less chemical goes in. It locks it to be in proportion.
Okay.
You then back that up with monitors that basically measure the level of the chlorine dioxide actually in there, which are the policemen. The monitors act as the policemen to say, yes, you've got a green light, you can go, or red, you've got too much chemical in there, we'll raise an alarm, or we'll take an action, or whatever needs to be done. They would suspend the dosing, for example.
Is this what you're referring to in your last paragraph on that page?
Yes, so the dosing strategy was proportional dosing based on water volume via impulse water meter with its monitoring and protection system, yes, using membrane electrodes to measure the amount of chlorine dioxide and chlorite where required, yes.
And did that monitoring alerting system work as far as you were concerned?
Yes, it did. It was tested and validated at commissioning, and it's tested and validated periodically anyway. and yes, and it does work. And in fact, that whole monitoring system is visible 24/7, 365, both through the BMS system and both to the service provider.
Okay. Slightly different topic, but also related to dose. Can I ask you about the idea of shock dosing? You haven't mentioned that in your statement, but can I ask you whether that was contemplated during the formulation of strategy?
The only place it was ever discussed was to do with wards 2A and 2B. Because when you look at the enormity and the volume of the water system, to shock dose it was impractical.
When you say impractical, why is that?
Because the amount of chemical you would need getting it around the system, the amount of people and monitoring that you would require to measure it at the outlets, it was too vast a task. And there is a big problem with shock disinfections. And shock disinfections are good if they remove all the contamination. But if they don't remove all the contamination, they have a habit of sometimes taking the surface off and exposing what's below. So you can actually then release things from shock disinfections that you don't want to release. And the problem you've got is once the shock disinfection is gone, you've nothing there then left to kill it. So either you do shock followed by continuous, or, as is often the better case, you actually dose continuously from day one and ignore the shock dosing.
Okay, you focused there largely upon the system as a whole, as I understand it. How might things have been different for wards 2A and 2B?
2A and 2B, because at the time they were unoccupied, we could actually set the dosing plant up to dose at higher levels. So we could dose it, if we wanted it, 2 or 5 parts per million to actually hit the pipework in that particular area. We could isolate that pipework.
And did that in fact happen?
Some of it did happen. I can't remember from memory what level we went up to.
Can I ask you about a completely different matter at the moment, just turning back to the operation of the chlorine dioxide group? There's 2 references in Bundle 27, Volume 1, I'm going to ask you to take a quick look at. Page 578 we have there. This is a minutes from 8th of November 2018.
Yes.
It's a meeting that you weren't personally present at, but you've sent your apologies, we can see. If we go over to page 579, there is a reference here to monitoring and test training plan at the bottom of the page.
Yes.
And it starts off by an indication that roughly 35 to 40 people will need system training. Now, this is being recorded on the 8th of November. I shan't take you through the other minutes, but in fact, this is an action point that's repeated throughout a series of meetings. Do you recall that?
Yes, I do. And I remember that in actual fact, Scottmas, who were the chlorine dioxide equipment provider, actually produced a video specifically for QEUH, Greater Glasgow and Clyde, for the chlorine dioxide systems at QEUH.
Do you recall when that was done?
I don't recall when that was done. But I do remember that training was done. But I can't give you the dates.
Right, perhaps, I don't think this was within your document list, but if we move on to page 660. No, it is within the list. 660 is another set of minutes from 15th of August. And if we look at, you are present at this meeting, and if we look at the middle of the page, we'll see that there's reference to completion having been achieved in March 2019. So this would have been minutes from August 2019.
Yeah.
Do we see in the first of the red paragraphs, about 2/3 of the way down the page, there's a reference again to the monitoring and test training plan.
So training is still not taking place and is now long overdue and posing a significant risk to the NHS. It was reported that dates are awaited from Mel Macmillan. Right.
Yep, and there's a reference below that to the training video, which is perhaps the one you referred to a minute ago, having been undertaken and awaiting final edit, and a screening was still to be arranged.
Yeah.
Now, this is 9 months after we first saw the reference to training being required, and it's recorded here that's a significant risk to the NHS. Have you got comments to make about that? How satisfactory is that from your point of view?
It is an unsatisfactory position to have been in, and that training should have been facilitated sooner. However, there were sufficient safeguards built into the systems, together with the off-site remote monitoring, to actually not cause it to be a significant risk. In other words, the monitors that were measuring the chlorine dioxide were all linked back to the BMS system. And they were also online, off-site to the service provider who had sight of all of those 24/7, 365.
Okay, but
with an email backup alert system.
Monitoring and alerts and so on, I can understand. I think you mentioned also that there might be other sufficient safeguards present. What might those mean?
Other safeguards would have been manual testing, so going around and doing actual physical manual testing with a chlorine dioxide test kit. Yes.
Okay. Well, I take it that monitoring and remote control would be would work more quickly, or would be more rapid as a response than relying on manual testing.
Yeah, I mean, the monitoring is automatic. If it hits the high level, then there is a predetermined course of action that it does.
Okay, the second point I wanted to take from the minutes is on page 581. I should go back to 578. Again, we'll recall that was recording. This was 8th of November, 2018 minutes. But the entry in 581 is under any other competent business, VOCB. Now, you're mentioned in the first paragraph there, but I'd like to ask you, insofar as you're aware of it, the significant issue that's raised in the last paragraph of that section. Significant issue was raised in relation to the fitted pipework within the main plant areas. It appeared that what's fitted doesn't match the as-built record information, and the pipework is instead a mix of non-standard Italian brands and Finnish pipework. Is this something you know anything about?
Yes, this got brought to everybody's attention so within the main plant room, you've got all your stainless steel pipework, which is all covered in insulation. To do the modifications that we required, we had to remove that insulation. When that insulation was removed and we were doing changes to the pipework, we identified two things predominantly. One was that the dimensions were not consistent, i.e. the stainless steel had come from different sources, and the dimensions were slightly different. So, for example, I think you had 150 millimeters and 154 millimeters. And the other thing that we identified was that some of the joints, what we call the crimp joints, where you actually join the two pipes together, had got significant issues in terms of the way the pipework was cut and finished, and the fact that they weren't fully assembled together, so they created a reservoir of stagnant water within them. So that was to do with the original installation.
Okay, and the significance of that, would it be the same as if there was any stagnant water pool within the water system?
Yes, the problem with the joint here is that obviously organisms can get up within that joint and they can start to grow and multiply, which we did identify. So we did identify that there were microorganisms in there, and I seem to recall on one occasion we did a measurement and had about 400 millilitres of water trapped within one of these joints.
Do you know if that was addressed?
It was addressed in so much as it could be addressed where the joints had become open, but to address it would mean you've got to revisit the whole hospital. So it's not a practical solution. But where we did find them within the work that we were doing, then it was addressed.
Okay.
But actually, you'd more like end up having to do every joint in the hospital, and that just wouldn't. You might as well repipe the whole thing.
Right. Thank you. Now, turning back to your statement, and it may be that this is the last section I need to ask you about. Page 71 should have question 12.
Question 12, yeah.
And this is, in a way, looking back, now that the chlorine dioxide programme is in place, is your company still involved in carrying out water tests? And what conclusions did you draw? And your answer is yes.
Yes, we are still involved in that. We do 6 monthly audit of the chlorine dioxide units and the service providers provision.
What have your audits shown?
The audits have shown overall that the chlorine dioxide systems are being operated very well. You will, out of 29 systems, you will always pick up something. But overall, the delivery of the chlorine dioxide is good, and the levels being achieved around the site are good.
The second thing that you detail there is some testing that's carried out.
So Ian Parry identified microbiological sampling to provide benchmark sampling so we could monitor the performance microbiologically. He identified a number of locations where we would regularly take samples.
Who does the sampling and who does the testing? Is this all carried out by Water Solutions?
No, the samples are taken by DMA Canyon, and the analysis is done through ourselves at the laboratory that we utilise, which is the Intertech laboratory.
Okay, thank you.
And
again, what has that shown?
It's shown that actually the chlorine dioxide regime is performing incredibly well. The failures are almost negligible on the microbiological samples that we get for what we are testing for. And bear in mind that we do not do NTMs on a quarterly basis or cuprovidis or anything else. We do the basically the alert organisms.
That was what I was going to ask you about. You've mentioned there mould, TVC22, etc. in the fourth section in your answer 12. Is that everything that you test for?
That's everything that we test for. I believe Greater Glasgow and Clyde laboratories may well test for other things. Those results are not shared with us, so I don't know.
So when it came to things like Legionella, cuprovidis, Stenotrophomonas, things that aren't on your list, these matters.
Stenotrophomonas is a Pseudomonas rooted organism. So but no, we don't do that. That will be done by Greater Glasgow and Clyde laboratory. We have the capability to do it, but we've not been asked to do it.
So with that caveat, perhaps, what conclusion do you draw about the safety of the water system?
So, based upon the results that we have got, I think it would be very fair to say that the current water system within QEUH is better than we see in many establishments, based upon the analysis of those organisms that I've listed.
How would that answer compare to the answer that you might have given at the start of your engagement in the middle of 2018?
Oh, well, the samples then were bad. I mean, we had failures. There were failures. The chlorine dioxide has brought the microbiological quality of the water back under control against those organisms.
And at the risk of asking you to talk your own book here, does it follow from that that your view would be that dosing, permanent dosing, is a good idea?
If you can provide a surety that your primary control measures are in place and that everything else is absolutely functioning as it should be, your cleaning regimes are spot on, your infection prevention controls and everything else are spot on, then you can more likely get away without the secondary control measures. However, in the environment that we're in and the challenge that microorganisms are presenting us with, secondary control measures are becoming almost obligatory.
When you say environment we're in, do you mean the environment that Queen Elizabeth is in, or environment that we as a country are in?
Environment across the country we're in. We've got aging water systems. We've got an NHS infrastructure that needs money. We've got components that have got wear. We've got water systems that may be failing to be balanced in terms of the hot and the cold, and the secondary control strategies give us that extra resilience. And certainly if you're looking at a new build, please put it in from day one.
That was, yeah, I was considering whether to ask you that question, but you've anticipated. Given that you went on to conclude that many of the problems that arose may well have originated in matters during the construction phase, what is the conclusion as regards, your conclusion as regards biocide dosing?
We have a number of sites that we've looked at over the years where they have installed a secondary control measure, typically chlorine dioxide, from day one, i.e. the pipe work's gone in and from the first wetting, that water has had a secondary control measure as part of it. And they have not had the problems that we tend to see with systems with builds that have not got it in.
Okay, can I ask you maybe as my last question for now, a different angle on the same issue, which is the chemical properties of chlorine dioxide itself, specifically upon the integrity of the fabric of a system. Could you comment upon that, please?
At the levels that we are using the chlorine dioxide at, i.e. somewhere between, let's say between 0.5 and 1 part per million, 0.5 is the drinking water limit. It is not the chlorine dioxide that is causing any degradation to the fabric. There are other things that will denigrate the fabric sooner. And actually, we have to consider what degradation does biofilm have? What does the polysaccharide layer have that comes from biofilm do to the pipework?
Does that have a comparable effect, potentially, to chlorine dioxide?
No, I think it's far worse than the chlorine dioxide. The chlorine dioxide does not typically have a detrimental effect on water systems at the levels that we are dosing at.
Okay, thank you. I have no further questions for you at the moment, but your lordship will have.
Yes. Mr. Wafer, what I need to do is check with the rest of the room. So I'm going to do is take a brief break just to see if there are any more questions for you. Could you be back with us, let's say at 4 o'clock?
Yes, I mean, I'll just stay on here and.
Right, well,
Yeah.
that's perfect because we can tailor our return to whenever Mr. McKeever has got the information he needs. Right. Well, we'll take 10 minutes if that's required.
Thank you, Mark.
perhaps heard no more additional questions, and therefore we can allow you to leave. But before you do so, can I thank you for your evidence this afternoon and the work that will have gone into preparing your witness statement. So thank you for that, but you're now free to leave us. Thank you.
Thank you.
Well, that's us for today, and the plan is to sit again tomorrow at 10 with Mr. Connell, I think. And,
I understand, yes.
Professor Leonard. Right. Well, can I wish everyone a good afternoon, and all being well, we'll see each other tomorrow at 10.